lesson 10.5, solve quadratic equations by completing the square. You should be on page 663. So I guess the first thing I need to address with you is, what is the purpose of this process that you're going to learn called completing a square? We have to go back to the last lesson, which you look here. Here's the last lesson you just completed, how we used a square root to solve a quadratic. Now remember, to use a square root, the problem had to be in standard form with b equaling 0. All right, we learned how to use square roots in lesson 10.4, standard form when b equals 0, this process worked. Okay? Now again, this technique that you learned in the last lesson only works when b is 0. However, if you complete a square, then you can use square roots to solve quadratics when b is not equal to 0. So in other words, the completing the square process in lesson 10.5 will allow you to use square roots to solve any quadratic in standard form, even if b is not equal to 0. So that's the purpose of completing a square. So what does it mean to complete a square? For an expression of the form x squared plus bx, so you notice this looks like it's in standard form, and then there'd be plus c, you can add a constant c to the expression so that the expression in standard form is a perfect square trinomial. If you need to review perfect square trinomial, that's in lesson 9.7 we learned about those. This process that you're going to learn is called completing a square. Here's how you do it. To complete the square, you add the square of half the coefficient of the term bx. And if you're like, what the heck is that? It's easy. In other words, take your b value, divide it by 2, and square it, and if you do this, if you do what I'm highlighting right here, you will have completed the square. Let's see that at work. The value of c that makes the expression, or find the value of c that makes the expression x squared plus 5x plus c a perfect square trinomial, so that's one thing they want you to do. And then the second thing is then write the expression as the square of a binomial. So let's complete the square. You need to do what I'm circling here. Take b, which is 5, divide it by 2, and square that amount. Now, if you put this in your calculator, it will be 6.25. So if we add 6.25 to x squared plus 5x, you'll have completed the square. That's the answer to part 1. Now, in the book, instead of 6.25, they just left it as a fraction. So what they have and what I have are the same thing. Now let's write this as a square of a binomial. Well, both of these are perfect squares. X times itself gives you x squared, and 2.5 times itself gives you 4.5. So the square, the binomial squared that gives you this trinomial would be x plus 2.5 squared, and that's what the book has here. They just wrote it as a fraction. I just completed the square. Okay? Let's try one together, then I'm going to have you try a couple. Let's complete the square here. So take b, which is 8, divide by 2, which is 4, and square 4, that's 16. So to complete the square, I would make c 16. And then if c is 16, this trinomial is a perfect square trinomial. It would be x, and think about this for a minute, 8 divided by 2 is 4. X plus 4 squared is the binomial that creates the binomial squared that creates that trinomial. I now want you to try, pause the video and try those two. Okay, so for number 2, to complete your square, you take negative 12 divided by 2, which is negative 6, and then you square that. That's positive 36, which is why you see I added 36 for c. And then the binomial that's being squared then would be x minus 6 squared. And then in 3, you take 3 and divide by 2, that's 1 1/2. 1 1/2 squared is 2 1/4, which is why 2 1/4 completes my square. And then the binomial squared would be x plus 1.5 squared. So now we know how to complete a square. So now we need to use that to solve our equation. The method of completing a square can be used to solve any quadratic equation, even if b is not equal to 0. To use completing the square to solve a quadratic, you must write the equation in this form. So start off by getting x squared and bx on one side and the constant on the other. In other words, get all those x's on the left, put the constant on the right, and you'll have this set up to complete your square and then solve using square roots. So here's a sample problem. And let's look at this problem. The x's are all on the left, and I have my constant on the right. The first thing I have to do is complete the square. So let's do that. I got to take negative 16, I got to divide by 2, which is negative 8, and I got to square negative 8, that's positive 64. So I'm going to write this a little different than the book. I have x squared minus 16x plus 64. Now, if you add 64 on the left, let me highlight this. If I'm going to add 64 on the left, I also have to go to the right, and where I see negative 15, I have to add 64 to keep my scale balanced. Now, this is a perfect square trinomial. This works out into x minus 8 squared. And here I have 49. Negative 15 plus 64 is 49. Now to solve this, I have to take a square root of each side. So I'll square root the left and I'll square root the right. The square root and square cancel. So I have x minus 8 on the left, and the square of 49 is positive or negative 7. And then add 8 to each side, and you get two answers. I'll write them over here. You get positive 7 plus 8, which is 15, and you get negative 7 plus 8, which would be 1. So 15 and 1 are your two solutions. Let's do another one. 2x squared plus 20x minus 8 equals 0. So now you notice I got to get all the x's on one side and my constant on the other. So step 1, you notice they added 8 to each side. So let's do that first. Let's get that constant on the other side, which gets me to here. Now, here's another thing. I'm going to circle this in the book. Avoiding errors. This is a big deal. You should get this in your notes. Before you use this method of completing a square, you have to make sure that the lead coefficient in front of x squared is 1. Okay? Big deal here. So when you look at this problem, is the lead coefficient 1? And I think you're seeing, no, it's not. Okay? So, I just noticed something. I circled the wrong thing. When I add 8 to each side, I get to here. Okay? I don't want the lead coefficient to be 2, so divide everything by 2, which will make this 1x squared plus 10x equals 4. Okay, now I can complete my square. 10 for b divided by 2 is 5, and if I take 5 and square it, I get 25. So we're going to add 25 to the left and 25 to the right. Don't forget to add it to both sides to keep your scale balanced. 4 plus 25 is 29. So we have x plus 5 squared. Now, do you notice this is a perfect square trinomial? X squared and 5 squared. There's my binomial squared. And now, to solve that, square root each side. I would get x plus 5 equals plus or minus square root of 29. Take away 5 from each side, and I'm going to get two answers. Let me write them here. I'm going to get positive square root 29 minus 5, and I'm going to get negative square root 29 minus 5. And when you put those in your calculator, let me color code this. This is going to work out into around a positive 0.39, and this is going to work out to a negative 10.39 roughly. Okay? We're going to have to round those to the hundredth. Let's have you try. Pause the video and try these three real quick. Okay, I'm back. This first question, we have to find out, we got to complete our square. Take negative 2, divide by 2, which is negative 1, and square that. That's positive 1. Make sure you add 1 to each side. Now, this is a perfect square trinomial. It turns into x minus 1 squared equals 4. You got to square root each side, so x minus 1 would equal, square root of 4 is positive or negative 2, and then add 1, and you're going to get 2 plus 1 is 3, or negative 2 plus 1 is negative 1. And then the other two, I wrote number 5 in blue up here. I got to complete the square. Take 10 divided by 2, which is 5. 5 squared is 25, which you can see I'm adding 25 to each side. That's a perfect square trinomial. It's m plus 5 squared equals 17. Square root each side. M plus 5 is about plus or minus square root 17. Subtract 5, and you're going to get two answers. You're going to get the square root of 17 minus 5, which is about negative 0.88, and negative square root 17 minus 5, which is about negative 9.12. And then the final one I did here in green, got to get the g's on one side, so take away the 27. We do not want the lead coefficient to be anything other than 1, so divide everything by 3 to get rid of that 3 in front. And that gives you, I wrote it down here, g squared plus 8g equals negative 9. Okay, do you notice how b is not equal to 0? We got to complete a square. So take 8 divided by 2, which is 4, and square 4. You got to add 16 to each side. That will complete the square. And then there's a perfect square trinomial. It's g plus 4 squared equals 7. Square root each side. G plus 4 would equal plus or minus square root 7. And then subtract 4, and you're going to get two answers. I didn't put these in my calculator. You can. You're going to have the square root of 7 minus 4 and negative square root of 7 minus 4. And then, in word problems, you decide to use a chalkboard to paint to create a chalkboard on a door. You want the chalkboard to have a uniform border as shown. You can see that in the picture here. You have enough chalkboard paint to cover 6 square feet. Find the width of the border the nearest inch. So you know area would equal length times width. So the area is 6. They wrote that down. Now what's the length? You can see the length here. The border's x. So the length would be, it's 7 feet for the whole door, but we're taking away x and x. We're taking 7 and taking away the 2x. There's my length. And then my width would be, the door is 3 feet, but I'm taking away x and x, 3 minus 2x. So there's my equation. And now double distribute. To simplify, I'll put double distribute here. And when you double distribute, you'll get this statement. Oh, that's a quadratic. And I can see b is not equal to 0. So if I want to use square roots, I have to complete a square. So let's do this first. Let's take away the 21 from each side to get all the x's on the right, which gets me to here. I can't have 4 in front. I need a lead coefficient of 1, so divide everything by 4, which gets you to here. And now we got to complete our square. Do you notice how b is not 0? It's negative 5. So take negative 5. Divide by 2, and square that amount. It gives you 6.25. Now the book wrote it as a fraction. 25/4 is definitely 6.25. Okay? That's a perfect square trinomial. So x minus 2.5 times 2.5 is 6.25. So x minus, that's 2.5 squared, would equal what they have here. If you combine those together, you'd have 5 halves equals x minus 2.5 squared, and then take the square root of each side, which gets you to here, and then add 5 halves to each side, and when you do that, you'll get your two solutions, which they listed here, and then you just put those in your calculator. 5 halves plus square root of 5 halves, which is about 4.08, and 5 halves minus square root of 5 halves, which is about 0.92. Now you got to check, because one of these, they don't, even though these are mathematical answers, that doesn't mean they're both real. Could my border be over 4 feet? Well, think about it. If this is 4 feet and this is 4 feet, That's already wider than the whole door. That's not a real answer, so I got to throw that one out. So the border could be a little less than 1 foot, okay? So it's about an 11-inch border. If I take 12 times 0.92 feet, that's going to be about an 11-inch border. Okay, I'm going to pause the video here. If you have any questions, make sure you ask in class.